Friedel crafts acylation. In this reaction, you are going to add what we call an acyl group. And the acyl group, I will show you to in a second. It has a carbonyl carbon in it. And of course, there's an alkyl group attached to that. So let's show you the product of this. So the reaction's outcome would be the following. So you can see what was added to the benzene ring in this transformation. So where is your acyl group? It is this one right here. I wanted to use a different color. Let's use a different color right here. Or you can think of it as this one right here. So that's the acyl group. Very well, let's look at the mechanism of this reaction. So very similar to the one we've seen in the alkylation mechanism. So you have your acyl chloride reacting with the Lewis acid catalyst. So you have the outcome that is like, again, where you have the chlorine is attached to the aluminum chloride. There's a negative on the aluminum and there's a positive on the chlorine. So this bond right here dissociates and it creates, and I'm going to show you how it would look like. It's going to create this group. So this group right there is your electrophile. Of course, at the carbon. Now it has a resonance structure where you can actually bring down these lone pairs to, and then you would form one of the lone pairs and you would form a triple bond there. That's part of the mechanism, but I'm not going to use it. I'm only going to use this because it's it just shows us the positive on the carbon, and it would be electrophilic enough to react with benzene. So then the next step is you bring the benzene ring, as usual. You probably know the steps by now. One second. And I'm going to just orient it this way. So your benzene attacks at that carbon, forming the following. And of course, there's the H right there. Positive is right there. Positive, the carbocation. So you're aware that there are two resonance structures. Make sure you know them. On a quiz or on a test, I might ask you to draw all three. We did draw them for previous mechanisms. Then you would expect the last step to be the same. So I'm just going to bring the outcome here. You have the Cl attached to the aluminum chloride. So once again, the bond attacks the hydrogen, and then those electrons re-establish or restore aromaticity. So you have HCl. You have also the aluminum chloride as your catalyst, which doesn't get used up. So that's the electrophile. This is that was used, and this is the entire reaction. Its mechanism is listed, and again, what's useful about it is you're making a carbonyl compound here. You're making a ketone because this is essentially a ketone.